Yeah. Okay, so 12.1 is just the basics of sequences and summation notation. So roughly speaking, a sequence is an infinite list of numbers with a specific pattern. For example, right here, 5, 10, 15, 20, comma, dot, dot, dot. The comma, dot, dot, dot means it goes on forever, right? Continuing at the same pattern. We've seen this before in Sec 3. So right here, we got to get down some notation here. So well, if you had to guess, 5, 10, 15, 20, what would come next? 25, then 30, and then so on. So once again, the dot, dot, dot means it continues forever. So this is what would be considered the first term in the sequence. This is how they would write it. So the notation is a sub 1. Now notice, a sub 1 is not a 1. People will see a sub 1 and think that the first term is 1. That's not what this means. That means we just are at the first term. So our first term is 5. This would be our second term. You guys see what a sub 2 means? Second term, third term, fourth term, and so on. So if I said to you, find a sub 7, I would be asking you to find the 7th term. That's like saying, what's the 7th term? So then you'd say, well, I gotta hurry and find that. So 20, 25, 30, 35, 40, let's see here, a sub 4, a sub 5, a sub 6, a sub 7. So a sub 7 is equal to 35. Okay, now a couple things that this is important to note is what a general statement for this would be. Right here, what a general statement. A sub n means the nth term. Now that could mean if it says find a sub n, that means find any term slash every term in the sequence. A general statement, a sub n. Nth term, obviously. So then when you see this, a sub n minus 1, the minus 1 is small down by the end. It's not a sub n and then minus 1. It's a sub n minus 1. So what that means is just, it literally means, think about it, if this is a sub 7 right here, if a sub n is a sub 7, what would a sub 7 minus 1 be? A sub 6. So you guys see how that literally just means previous term from a sub n. So that's important to note. Whenever you see the a sub n minus 1, that's not actually minusing 1. That literally just says, anytime I see this, I literally say, so we're taking the previous term. That's what that means, super important. That just says take the previous term. And then obviously then a sub n plus 1 would be the next term. So just keep that in mind as we go forward. Okay. Because we're going to have to write general formulas for this, and that's where this stuff's going to come into play, this general stuff. And you have to know what it means. This stuff isn't confusing if you really know the notation. I think it can be confusing if you don't know what it's saying. Okay, so let's test your abilities. Let's just test them. I wouldn't take notes here. You're going to get more out of this by watching. Here is 5, 10, 15, 20. If I said a sub n is 15, then we're looking here. What would a sub n minus 1 be? 10. What would a sub n plus 1 mean? 20. Okay, good. Awesome. All right, so we can write two types of formulas for this particular sequence, 5, 10, 15, 20. I would write this down. A direct formula, I call it. The book didn't call it a direct formula. They didn't call it anything. But I'm gonna call it a direct formula because it's a formula that you can plug directly in to get back the sequence. So for example, a sub n is my general formula. It says this literally says the nth term or any term in the sequence is going to equal 5 times whatever n is. Now, direct formulas are the most useful because we can plug directly in. Now let's see why this makes sense. Here's a sub 1. If I plug in 1, do I get 5? Guys, look, I'm plugging in a sub 1. So we would have 5 times 1. Do you guys see how we're getting 5? This is a sub 2. Look, a sub 2. Do you guys see how that would mean plug in 2? So I'm getting 10 and a sub 3. No. This is particularly to create 5, 10, 15, 20. All right. Now, recursive definitions. This is, sorry, I'm going to move this up. A direct formula is the one that you can plug directly in. A recursive definition is a definition or a formula that it's written in terms of the previous term. It's a general formula that will also recreate 5, 10, 15, 20, but it's written in terms of the previous term. You'd have to know the previous term. Now, for example, look at what this formula says. To create 5, 10, 15, 20, look what it says. For any term in the sequence, we've got to take the previous term. Isn't that what that means? Take the previous term and then add 5 to that. And then it says, given that your a sub 1 is 5. Now, you'd have to have given that a sub 1 is 5 or you wouldn't know where to start. Does that make sense? So, look, that literally says, okay, start with 5. Then take the previous term, which, okay, right, here's the previous term, and add 5. So what would we get? 10. So now do a sub 3. That says take the previous term, which is 10, and add 5. You guys see how it's just recreating it, but in a different way. So this is the formula that I feel like is the easiest to write, but it's really not that usable, because if I said to you, find a sub 38, you would have to know the 37th term and then add 5 to that. So you'd have to go all the way out. That would take a long time. But right here, wouldn't I just plug in 38? So I like direct formulas better. We haven't learned yet how to write this. But I'm just stating that it's more useful. So these are easier to write because it's just what do you see happening, but these are easier to use. Okay, so let's just do an example of we're really just doing basics today. Like really it is just the basics. So let's look at an example. It says write out the first 5 terms for the following sequences. Alright, so let's do that. So this is given a direct formula, isn't it? So if we're given a direct formula, we just start plugging things in. We want a sub 1, a sub 2, a sub 3, a sub 4, and then a sub 5. Let's plug it in. So if we plug in 1 here, 2 times 1 is 2, minus 1 is 1. Then comma, plug in 2. 4 minus 1 is 3. Plug in 3. 6 minus 1 is 5. Plug in 4. 8 minus 1 is 7. Do you guys see a pattern happening? So what do you think would come next without even calculating? Correct. Pretty easy, right? Plug it directly in. Yes. Right, because this is the direct formula. So let's look at another direct formula here. So it says find the first 5 terms. So what's a sub 1? Plug in 1. So that would be negative 1 to the first divided by 2 to the first. So wouldn't that be negative 1/2? Comma. Okay, let's find a sub 2. You plug it directly in. So that'd be negative 1 squared divided by 2 squared. So wouldn't that be positive 1 over 4? Comma. Okay, let's do one more, then let's see if we can see a pattern so we don't have to keep calculating. Negative 1 to the 3rd power divided by 2 to the 3rd power. Won't it be negative on top? Negative 1 and then divided by 8. Can you guys see a pattern here? I can. Comma, if you were going to make a guess, what would be the top of the next one? Positive 1. What would be on bottom? Yep, aren't you times by 2 each time? The next one would be a negative 1, and on bottom would be 32. So you'll kind of look, once you've done a few terms, just look for the pattern and finish it off, but you can keep plugging things in. Okay, let's find the first 5 terms for this thing. So you'd say, oh, this is a recursive definition. This says take the previous term and add 2, starting with the first term of 3. So that says 3. Now take the previous term 3 and add 2. 5. Take the previous term and add 3. So that'd be 5 plus 2 is 7. You guys see how it works? Take the previous term, add 2. 9. Take the previous term, add 2. 11. You see how they just work differently. One with plugging directly in, one using the previous term. Okay, let's do this one. It says find the first 5 terms, given that the a sub 1 is 1. Then look at this formula. It says take 3, plug in the previous term plus 2. So what would be on my inside here? 3, and then 1 plus 2. So won't that be 3 times 3? 9. Okay, let's plug in. Look at this. It says previous term. You got to make sure you're doing previous term, not plugging in 3 here. Do you guys see what I'm saying, people? Because it gave it to you. So then right here it says take the previous term, add 2 to that, and then times it by 3. So what was our previous term? 9 plus 2 is? 9, 10, 11, right? 9, 10, 11, yeah? 11 times 3 is? 33. Okay, let's do the next one. This says take the previous term, which is 33, add 2, so that'd be 35. 35 times 3. Thanks, you're the best. And so on. I think we get the picture here. Are we good with this? Okay, so just do 2 different formulas to create the same thing. You just go about it differently. One you're plugging directly in, the other one you're using the previous term. Okay. Alright, so let's go ahead and we gotta just notice we're not getting into extremely difficult stuff today. In the next few lessons, we'll learn formulas that I can give you that will work every time given a specific instance. Today we kind of have to just use our logical thinking skills, so I'm just going to point some things out to you, okay? If I said to you, find the equation for the following sequences, then there's 2 types of equations, a recursive definition, right, and a direct formula. So right now we're just looking at creating a direct formula for this. So a couple of things to know. What do we see happening here on top? 1, 3, 5, 7. We're adding 2, aren't we? Or they're all odds, aren't they? And then on bottom, we're adding 2 as well, aren't we? We're adding 2 on top and we're adding 2 on bottom. The bottom, though, is evens, isn't it? Okay, so a couple things to note, everybody. This, I would write this down. 2n will create even numbers. Now let's think about why that would work. Let's plug in a 1. What's 2 times 1? 2. Plug in a 2, you get 4. Plug in a 3, you get 6. You guys see how the 2 is making us skip the odds? It's making it always be even. Now what would create an odd number is if we have 2n and then we subtract 1 off that, that would then pull you back into the odds. Think about that, how that would work. If I take and plug in 1, I get 2, don't I? And then 2 minus 1 would be 1. So that'd pull you back. It would be like even. Subtract 1, now we're at the odds. So if I plug in 2, I get 4. Minus 1 is 3. You guys see how that pulls us into odds? And then right here, negative 1 to the nth power will create a bounce between a negative and a positive. Now that makes sense. Each term will be positive then negative, or negative then positive, negative then positive. Because think about it. If I plug in a 1, I'm going to get negative 1. If I plug in 2, 1, I get positive 1. 3, negative 1. 4, positive 1. So this would create a bounce between positive and negative. So let's see if we can create a formula. Now often when you're doing this fractions, you literally just create a formula on top divided by a different formula on bottom. So what would be our formula that would create 1, 3, 5, 7? 2n minus 1. Good. And then what would create 2, 4, 6, 8? 2n. Now isn't this the formula that's going to create this? Let's try. Plug in a sub 1. On top we get a 1 and on bottom we get a 2. Check. Let's do a couple more. Let's do a sub 2. 4 minus 1 is 3 and then on bottom we get 4. You guys see how it's working? So we've created a general formula. Okay, let's do it on this side here. Okay, what do we see? 2, 4, negative 8, 16. So you see it bouncing between positive and negative. So you have negative 1 to the n, right? Would it be just 2n though? It is even numbers, but this creates even numbers in a row. Do you see how we're not just timesing by, we're not just adding 2 each time? This is actually geometric. So, let's think, how can we do this? Let's think here. This one, we're actually, aren't we timesing by 2, not adding 2? Yes. You said, so parentheses 2 raised to the n? Yes, because isn't that timesing by 2 each time, guys? Think about this. If I plug in a 1, I'm going to get 2. If I plug in 2, I'm going to get 2 times 2, aren't I? Because isn't it squared timesing? So I'll get 4. If I plug in 3, that's 2 times 2 times 2. Do you guys see how that's working? Yeah, sure. Either one will work. So it's just a formula that will work as long as it's correctly written. Okay, awesome. So right now today we're just thinking critically. We're not learning an exact way of creating a formula. The next few times we will. I'll give you a formula that will always work, but with this one. All right, so this is just something I'm going to briefly bring up. It's not super important. It's in the book, so I wanted to briefly talk about it. So this is like, what pattern do we see happening here? Let's see if you can figure it out. We have 1, 1, then 2. Then 3, then 5, then 8, then 13, then 31. Can you by chance see where they're getting the next term? Yeah, they're adding previous terms. So 1 plus 1 is 2. 2 plus 1 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Yes, that's what's called the Fibonacci sequence. So a mathematician, last name Fibonacci, figured out that this phenomena happens in the real world many, many times. So these are all examples of Fibonacci sequence. So I personally haven't really used it, but it's how it's being split up in a way. So it starts out small and then it gets larger. I don't really know. I just wanted to, they said sequences in the book, it's like sequences are used in this Fibonacci sequence is seen all over in real world settings. So it's kind of this what they call the golden spiral. So just if you find that interesting, great. All right. We are now to what's called a partial sum. So it says, in calculus, we oftentimes have interest in adding up the numbers in a sequence. We're not learning any calculus today. We're just learning some basic just literally learning how to add a sequence, which is not hard. It's just in the future, if you do take calculus, there's a lot of times when we actually do want to add things up. That's actually called a series. So right here, if I said 2 plus a fourth plus an eighth plus ... right here, instead of commas, it's now just addition signs. We're finding a sum.
Teachers, don't forget to calculate in the lecture hall starting at 7.
So everybody grab a calculator real quick. So it says, what is the first 4 partial sum? Now why it's called a partial sum is we're only taking the sum of the first 4 terms. That's only partial. It's infinite, right? So this is why they're calling it a partial sum. Because they are telling you when to stop adding, so you're only taking a sum of partial of the sequence. So do a half plus a fourth plus an eighth, and then if we are doing the first 4 terms, what would be the next term to add? 1/16, right? Look for a pattern, recreate that pattern. So what do you get? I guess I'll accept the decimal for now, but we would probably, I'll accept the decimal. 0.9375. Cool. If we were doing this by hand, since we only have our little calculators, we'd have to go and get a common denominator, which wouldn't be that hard, but I'm okay with decimals. Okay, so it says, what is the first 4 partial sum? So that just means take the first 4 terms and sum them up. So let's just find the first 4 terms. This is a direct formula, is it not? So that would be parentheses 1 minus 1 over 1 plus 1 is 2. Then we're adding, because it's a sum, plus, let's find a sub 2. So that would be 1/2 minus 1 over 3. You guys see where we're getting this? We're just plugging it in. Yeah, 1 divided by 1 is 1. Minus 1, and then 1 plus 1 is 2. Just plugging it directly in. Then we have plus, parentheses. Let's find a sub 3. Guys, this is 1/3 minus 1/4. We're finding the first 4, so we have 1 more, plus, parentheses, plugging it, so we're finding a sub 4, plugging in 4, so that'd be 1/4 minus 1/5. So to do our math here, what they're wanting you to see is, let's say you're doing this by hand, you could just type it in your calculator, but if you recognize a few things, then your life's going to be easier. Isn't this minus 1/2 plus 1/2? Minus 1/2 plus 1/2? So that's gone. We don't even need to worry about that. minus a third plus a third, true? Minus a fourth plus a fourth. So the only thing we need to add up is 1 plus negative 1/5. I mean, if you were to do it the long way by your calculator, you'd get the same answer. 1 plus negative a fifth. 4/5. We plugged in 1 into our formula. 1 over 1 is 1. Minus 1. 1 plus 1 is 2. We're just plugging it into our formula and summing them up. Okay, so now this is the last little piece of the lesson here. Is writing, instead of having, summation notation. I'll just read it first and then I'll explain. Summation notation is the same exact thing as saying take the sum. It is just writing it a special way. So right here, guys, I'm saying take the sum of 2 plus 4 plus 6 plus 8 plus 10. You guys see what I said here? Well, we can write that it's just the exact same thing as 2 plus 4 plus 6 plus 8 plus 10, but in what's called summation notation. So write this down. This is how you rewrite something in summation notation, and this gets confusing for people, so focus. This literally means take the sum. That big sigma sign literally just means add, guys. Add. That's all that means. Now, right down here we say the lower limit or starting point. Like how many, where, like not what are we starting at, but how many terms are we going to sum up? So you'd say n equals lower limit to the upper limit. Upper limit is where you're stopping, summing up. How many terms you're stopping, summing up. Now guys, make note of this. This and this are number of terms you are adding. That's all that is. The number of terms you're adding, not having anything to do with the actual term. And then right in here is the equation that would recreate the sequence at hand that you're summing. So there are many different sequences I could be adding. This equation gives us our equation or our sequence in particular. So look right here. I want to sum up. Right here we have 2, 4, 6, 8, 10. Now if I say to you find the sum, you could write it like this, true? Another way if I say take the sum is to write it in summation notation. So we'd say, okay, if we're asked to find a sum, we're going to do a sum sign, a summation sign. That means add. Now how many terms are we adding up? 1, 2, 3, 4, 5. So what do I put at the bottom? 1, because I'm summing up 1 at the top, stopping point 5. You guys see how those have nothing to do with the 2, 4, 6, 8, 10. We started at the first term. So this, once again, see, look how this says it's the number of terms you're adding up. So we're literally saying start with the first term and add to the 5th term. So what if I would have said sum these up to 8? You would have said, so we're only summing up the first through 4th term. Does that make sense? And then the 2n is what particularly the formula, the direct formula that recreates 2, 4, 6, 8, 10. Because how do we get 2, 4, 6, 8, 10? By this formula. Plug in 1. Look, plug in 1. What do we get? 2. Plug in 2, we get 4. Plug in 3, we get 6. Plug in 4, we get 8. Plug in 5, we get 10. Do you guys see? So if you see this, you can rewrite it in this form. And if you see this, you can rewrite it in this form. Do you guys see how we can switch back and forth? And then they just mean the same thing. You have to be able to switch back and forth. Okay, let's do this. So it says, this says, find the sum of the first through third terms. So let's figure out what the first through third term is. How can I figure out what the first term is here? What is a sub 1? Plug in 1. So that would be 2 times 1 squared, which is 2. Then we have plus, that's what the sum sign means. Let's find a sub 2. Then we just plug in 2. So that'd be 2 times 2 squared. Isn't that 8? Plus, let's find a sub 3. So plug in 3, that would be 2 times 3 squared. 9 times 2 is 18. Now, we're stopping because we were told to sum up the first through third terms. 18 plus 8, so that would be, let's do this. This will be easier. 8, 9, 10, right? So 28. So the answer is 28. Make sense? Okay, let's do this one. It says find sum. It says sum the third through fifth term. So where would we start? A sub 3 plus, we need to add up a sub 4 plus a sub 5. You guys see how we're starting the third through fifth terms is what we're summing up. So let's plug in 3. 3 minus 2 is 1. Plug in 4. 4 minus 2 is 2. Plug in 5. 5 minus 2 is 3. Do you guys see how we did this? 5, 6. So the answer is the sum is 6. So pretty straightforward as long as you know what the sum sign means. Okay, now what we're going to do is we're going to take and write the following in sigma notation. This is super important and hard for people to do. It's really easy though. So let's look here, guys. Looking at this, how many terms are being summed up here? 7. 1, 2, 3, 4, 5, 6, 7. Does everybody see how there are 7 terms being summed up? So you'd say, because I have addition signs, I write my sum sign. Now we're summing up the first through the 7th term. Now how did they create this formula? Like what's happening here? They're cubing, so everything's being cubed, so you're saying something cubed, right? N cubed. Look, 1 cubed, 2 cubed, 3 cubed. Isn't that n? A sub 1. 1 cubed. You guys see how n would be 1? Right. We can always write, if they ever ask you to write the following in sigma notation, we can always call this our first term. But, so you can do that, but then it's a little bit harder to write the formula. So it depends. Like you'll see in this next example, we're going to actually call this we're going to say starting with the third term. Yes. Correct. Yes. So we haven't actually found the sum, have we? We've just rewritten it in the same, we're saying the exact same thing here and here, aren't we? But we're just doing what it asks us, writing it in sigma notation. So let's look here at this one. We're doing the sum. Now with this one, we could call this our first term. Or let's see if that would be hard though to write the formula. So let's say right here, like so we have 3, 4, 5, 6, 7. So yeah, let's start at n equals 3 just because then the formula will be easier to write. Because then it would be, what would the formula be here? The square root of n. You guys see how that would make it easier to write the formula? Because then we're starting at the third term, that would be plug in 3, 4, 5, plug in 6, then so where are we ending? At plugging in a 7. So now what I'm saying is you could have called this the first term, second term, third term, fourth term, fifth term. Now, so then you would have went sum from n equals 1 to 5. But now the problem is to write this formula, you need to be able to plug in a 1 into the formula and get this. So then that would have been the square root of you said what? You could see if that would work, and if it works, so you said n plus 2. Let's see if that works though for all of them. If I plug in 1, I get 3. If I plug in 2, I get 4. If I plug in 3, I get. If I plug in, you guys see how that one would work? Either answer is equally acceptable. Okay, awesome. Okay, right here, so find the sum of, where do you want to start? Maybe start at 1, because what's happening here? Are they all evens? And we're just adding 2. And remember that formula I gave you a minute ago? So 1, 2, 3, 4, well, how many terms is that? Nope. It's 10, isn't it? Starting from 2 up to 20, do you guys see how it's adding 2 each time? So that's how many units? From 2 to 20. And then do 20 divided by 2. 20 minus 2 is 18. 5 by 2 plus 1. Okay, yes. Okay, so this would be 10. So then what would our formula be here? 2n was how we got evens that we're adding by 2. Okay. Which makes sense, right? If we go 2 up to 20 and then we only have half the numbers, that would be 10. Okay, awesome. Okay, so this is the last thing that we're actually done. It says the properties of sums. I don't even think you need to write it down. I really don't. Okay, this just says if you have the sum, but if you want, you can. You have this, if you have the sum from n equals 1 to k of a plus b, if you would like, you can split it up and do the sum of 1 to k of a plus the sum of 1 to k of b. So you guys see how you can just do them individually? Addition, you can add the first plus add the second, if that's easier to you. That sometimes isn't easier. You can sometimes, if you'd rather just keep them together, you could. So we have the sum of a minus b, so you could just split it apart, is the same thing as saying. And then if you have the sum of some number times a, you can pull out the number in front. That's like a constant. So if you're timesing by 3, you can have it in front or inside. It won't matter. So you can just times the number at the end or at the beginning. It doesn't really matter. So let me just give you an example of that. So right here, if we wanted, it says find the sum of the first or third term. You don't have to split this up. You could leave it. What would I do? If I wanted to not split it up, I would just plug in a 1, wouldn't I? Find out what my first term is. So that'd be negative 2, 1 plus 1 squared, which is negative 2, parentheses, 2. So our first term is negative 4, then plus, then we could plug in, this is a sub 1, a sub 2, wouldn't that be negative 2 times 2 plus 2 squared? So that'd be negative 2 times, so negative 2, this is a 4 plus 2, which is 6, so that's negative 12. You guys see what I did? So you don't have to split it up. I'm going to do the last one split up because they want you to see it. So we could find a sub 3. So that would be, if I plug, well, I feel like it's so much harder just to split the dang thing up. Because then what you do is you pull out in front negative 2, and then you would have the sum of negative 2, parentheses, sum of n plus the sum of n squared. So let's do, that'd be negative 2 and then parentheses, the sum of, you could distribute the negative through. So n is, we're at 3, aren't we? So that'd be 3 plus 9 I know. That makes it harder, I feel like. And then we have 27. No, we don't. 9, 10, 11, 12. 12 times negative 2. Negative 24. So I feel like splitting it up is just harder. Honestly. We plug it directly in. Okay. So then you would just add those up. That is the end of the lesson. So if you ever see this, don't worry about splitting it up. Plug it directly in. Easier, easier.